Hello everyone, I'm Tanjeena. On behalf of our group, I'm presenting department store sales forecasting in Australia using time series analysis. For this analysis, we used retail turnover data from the Australian Bureau of Statistics. From the time series plot, we can tell that this data has linear increasing trend. There is seasonality and changing variance present in the data. The behavior is mostly autoregressive, but can be affected by seasonality. There is no changing point in the data. The ACF plot further presents that there is repeated patterns, which indicates strong seasonality. The PACF plot has no pattern. There's multiple lags outside the border, indicating autoregressive. Because of changing variance, we applied Box-Cox transformation. On the data, we applied stationarity tests. The ADF and PP test says the data is stationary. However, the KPSS tests says the data is non-stationary and which matches with the time series plot. So we applied first difference on this data to remove the non-stationarity. After first difference applied on the data, all the tests are now saying the data is stationary. The ACF plot, however, still has seasonal effect. Therefore, we applied seasonal difference on this data. After applying seasonal difference, now we have a time series plot which has no seasonality. The ACF plot also indicates there is no repeated pattern, so there is no seasonality. The PACF plot showing that there is less autocorrelation in the data now. From this stage, we explored more to find out the different parameters of SARIMA model. Using residual approach, we find out that the SARIMA model with seasonal parameters 1, 1, and 2 works best for this data because with this model, the ACF plot has no seasonal spikes. Therefore, we select these parameters as our seasonal parameters. After selecting the seasonal parameters, we use classical approach to find the other parameters of the models. We applied ACF, PACF plots, EACF matrix, and BIC table to find out this parameter. After applying all these methods, we find these models listed on the slide to be our chosen model. On this model, to find out the best fit model, we applied AIC, BIC matrix, ML, and CS method to fit parameters of the models. And after these steps, finally, we selected that the SARIMA model with regular components 6, 1, and 4, and seasonal components 1, 1, 2 with seasonal component 12 to be our best model. After the model being selected, we applied diagnostic checking on this model. If we look at the residual plots of this model, there is no trend in the residual plot. The QQ plot mostly fall on the line. However, the twins does not fit the line, which indicates it is not normal distribution. The ACF plot has seasonal uh, doesn't have seasonal legs outside the limit. The June box plot, it suggests that there is still autocorrelation left in the residuals. However, all the points are outside the limit. Therefore, we use this model to forecast our data. As you can see from the forecast plot, that the forecast points closely match with the historical data. Therefore, we can say that the model is very reliable for this forecast. With this, I'm ending our presentation. Thank you very much for your time.